Okay, this is going to be the last video here. We're going to learn how to find percents under any normal distribution. So what we're actually doing here is we're going to put together what we learned on the last video with this the standard normal table. We're going to put that together with the z-score formula that we learned in the first video in order to find areas for any normal distribution. So just recall the example I gave. I said heights of adult males are normally distributed with a mean of 69 inches and a standard deviation of 7 inches. Okay, and so we actually showed here that you could lay out the distribution. So if the mean was 69, standard deviation was 7, you would have 1, 2, 3 standard deviations above, -1, -2, -3 standard deviations below. So you would be adding 7 here. This would be 76, 83, and 90. This would be 62, 55, and 48, right? And then you could find a z-score for any value. Like let's say 50, we're interested in 50 here. We're interested in that value, and I want to know what the z-score is for that. Okay, so these are the z-scores: 1, 2, 3, -1, -2, -3. So the z-score I'm looking for is going to be somewhere between, -2 and -3 there. So the formula that we used was, I'll write it up here, z-score formula. It is that you take the value that you're wanting to convert, you're subtracting the mean, and then you're dividing by the standard deviation. So for this one here, I'm taking 50 minus 69 divided by 7. So you're using that along with these two in order to find the z-score. So it'll always be the x-score first, even if it's smaller, because you want to get a negative z-score here. So that's -19, and I divide that by 7, and I get -2.71. -2.71. So here is the big idea, is that all normal distributions are really the same relative to their z-scores here. So any normal distribution, no matter what the mean and standard deviation is, will still have the same percentages given the z-scores. So like between -1 and 1 will always be 68% for any normal distribution. Okay? So if you wanted to know like what percent of adult males are actually shorter than 50 inches, well, the z-score for 50 inches is -2.71. So I could look that up on my table. And if I do that, so -2.71, I get 0.0034. Okay, so that's the area below that z-score, which is also the area for, that's the decimal form of the percent. So the percent would actually be 0.34%. Okay, so this would actually give me the percent of the population that's shorter than 50 inches. Okay, it'd be 0.34% of the population of adult males. Okay, so just a fraction of 1%. So that's the idea. So basically, we're using this table, but before we can use the table, we got to get the z-score first. Okay, so when you do these, I encourage you to draw a diagram. So let's use the same example, and let's say I want to know what percent of adult males is taller than 80 inches. Okay, now when you draw your diagram, you don't have to list out 1, 2, 3 standard deviations each time. You don't have to list all that out. In fact, I encourage you not to, because it just confuses the issue. So just put the mean and standard deviation in the center. Now 80 inches is a little over 1 standard deviation above the mean, so maybe about there. It doesn't have to be perfect. It's just important that I get it up above the mean, and that it's important here that I want the ones that are taller. And so that would be this portion of the distribution. So I'm actually doing a greater than problem. So that's like the second case. We learned those 3 cases: less than, greater than, between. Okay, so in order to find what the percent is, what this percent is, I'm going to find the z-score for 80. So it'd be 80 minus 69 divided by 7. 80 minus 69 divided by 7. So that's actually approximately 1.57. So what I do is I look up this z-score, okay, to find the area below that z-score. So that's a positive 1.57. 1.57. And I get 0.9418. Okay. So that's the area below 80. So to get the area above, I do 1 minus that, which is 0.0582. Okay, and so what percent of adult males lies above 80 inches? My final answer would be 5.82%. Okay. So you can use this then to solve application problems, just like this. So let me do another one. So let me say that the wait time at a popular restaurant is normally distributed with a mean of, let's say, 24.3 minutes and a standard deviation of, we'll say like 3.6 minutes. Okay. So let's say then I want to find what is the percent of customers that wait between, let's say 25 and 30 minutes. Okay, what's the percent of customers? Notice this is a between probability, and so it's like that third case. We're going to have to find a z-score for each one of those, and then subtract, look them both up and subtract the 2 areas. So let's actually draw this out. So my mean is 24.3. My standard deviation is 3.6. So notice both 25 and 30 are above the mean, but 25 is not very far above the mean. Only a little bit. 30 is a little further away. And I want to get the area between these two. Okay? So in order to do that, I got to find the z-score for both 25 and 30. So I'd have 25 minus 24.3 divided by 3.6. Okay. So 25 minus 24.3 divided by 3.6. And that's like 0.15. So that's really close to the mean. Okay, so now what about the 30 there? Okay, so that would be 30 minus 24.3 divided by 3.6. So 30 minus 24.3 divided by 3.6. And that's like negative, oops, I messed that up. Let me do it one more time. 30 minus 24.3 divided by 3.6. So that's like 1.58. 1.58. So this z-score is like 0.51. It's hard to write it here. And this z-score is 1.58. So you're finding the area between those two z-scores. So they're both on the positive side. So if I look up 1.58, I get 94.29. So 0.9429. And then 0.15 gives me 55.96. So 0.5596. So then I want to get the area between those two. 9429 minus 0.5596. 9429 minus 0.5596. And that gives me 0.3833. And that would be the decimal form of 38.33%. So what customers wait between? What percent of customers wait between 25 and 30 minutes? 38.33% of the customers. Okay, so that's how these are done. What you're doing, you're pretty much using what we learned in the last section to get areas from this table. There's the three cases where you either want the area below, the area above, or the area between. You can get that by reading the problem. And then I would draw a diagram like that. Go ahead and find the z-scores. This is the step we're adding because you can't look up these numbers on, I can't look up 25 and 30 on that. That doesn't make sense. I got to find the z-scores first, and then I look up the z-scores, and then I can get the area. So that is how we use the normal table combined with the z-score formula in order to solve these normal probability problems.